All right, so here is the test review answer key. So this one says, list all numbers from the given set that are numbers of the rational numbers. So rational numbers are going to include your, starting with your natural numbers, your counting numbers, which would be, let's see, 1, 2, 3, 4, 5. So counting numbers are 4. Then we have square root of 4, which is actually 2, so that's going to be a counting number, and that's all I see. Then we go to whole numbers, which include 0, and we do see a 0 right there. So we use 4, 0, square root of 4. After that, we have integers, which include positive and negative whole numbers, so I see negative 19. And then after that, we get to rationals, and rationals are going to be your fractions. So we see 7 over 8. And then we have, after fractions, we have decimals that they can repeat and decimals that terminate. So 0.6 repeated and 0.77. And irrationals are things that are not, like, so irrational would be like the square root of 6, pi, Euler, e, and so on. So there's my answer for rational numbers. All right, the next one says, state the name of the property listed. So for this here, they're both being addition, so I know it's an addition property, and we have two things we usually talk about, commutative and associative. So commutative is when you change the order, and associative is when you change the group. So in this case here, we have 1 plus 7 plus 8, and then 7 plus 1 plus 8. So we didn't change any groups, we actually changed the order from 1 plus 7 to 7 plus 1. So this would be considered commutative property of addition. Now for this one here, we have 11 plus, in parentheses, 4 plus 5, and the second one equals, parentheses, 11 plus 4 plus 5. So you can see we changed the groups, and the order is still 11, 4, 5 in both of them. So this would be the associative property of addition. All right. From here, number 4, we're going to solve our literal equation here. So let's go ahead and take a look at this one. So it says to solve it for n. So the first thing I'm going to do, let's write this equation here. So let's see, a equals p parentheses 1 plus n times r. So the first thing we want to do is divide both sides by p. And that's going to give us a divided by p equals 1 plus n times r. And actually, you don't need the parentheses after that. So the next step to get nr by itself is we're going to subtract that 1 to the other side. So we have a over p minus 1 equals n times r. And to undo that, we're going to divide both sides by, we're solving for n, so we're going to divide both sides by r. So my final answer becomes n equals a over p minus 1 divided by r. And there's our answer for number 4. All right, for number 5, I'm going to go ahead and multiply these two together. So we're going to get the square root of 9 times the square root of 63. So let's put 9 times 63 in our calculator here. So let's see, 9 times 63. And we get 567. And then x times x is x squared. So let's make this a little bit. All right. So here, I'm just going to do the square root of 567, and that gives me 9 square root of 7. And we know that x squared is really x times x, so that's a pair. That's going to come on the outside. So we have 9x square root of 7. All right. Now for number 6 is very straightforward. You can either type that in the calculator, or you could kind of just split this apart. The square root of 64 divided by the square root of 49. The square root of 64 is 8, and the square root of 49 is 7. And then last, for number 7 here. So sorry, it's all kind of together. It's just not a lot of space. So for number 7, We have the square root of 9 divided by the square root of 2. So you know that we cannot have square roots in the denominator. So we're going to multiply by the radical in the denominator to rationalize it. So it removes the radical. So we're multiplying the top and the bottom by the square root of 2. So we have the square root of 18 divided by the square root of 4. We know the square root of 4 is 2. And the square root of 18, once again, if you can't remember it, you can just do the square root of 18. The calculator will tell you 3 radical 2. So we look to reduce this, and that doesn't happen, so there's our answer. All right, on to number 8. So for number 8, what we're going to do is we're going to evaluate the function at the given value. So this one, we're saying x is -2, and for this one, x is -4. So we're just going to simply plug this in for x. So 7 -2 squared minus 3 times -2 minus 5. And that's going to give me 29 once I work it out. And for the one below it, the same thing. We have parentheses -4 squared minus 6 over parentheses -4 cubed minus 3 times -4. And when you work this out in the calculator, you get -5 over 26. And when you're doing this problem, you want to do n over d from the calculator. So n over d is right there. So you want to push that button and type in the top fraction, arrow down, type in the next fraction. That way so you get the nice fraction at the end. All right, for 10A, B, and C. So we have 3 types of things going on here. First, we have increasing. So if we think about a graph, increasing from left to right goes up. Decreasing from left to right goes down. And constant is a horizontal line from left to right. Okay. Now, so we're going to label our things here. So if I'm looking at this graph on the left side, from left to right, this increases. This is constant. This decreases. And this is constant. Now, where is it increasing? And we'll get, once again, this is with the values of x. So our intervals of x, actually. So most important thing is we're using the intervals of x. So this starts at -infinity in terms of the x-axis, and it goes all the way to this value, and we're looking at the x, which is 2. So -infinity to +2, that's where it's increasing. And use parentheses here. And that's the only place it's increasing. So decreasing, we can see it starts from this point, and it goes down to there. That's decreasing, so that's going to be from 3 to 6. And again, you're going to see me use parentheses. And then for the constant one, where is it a horizontal line? So from 0 to 3. Union, our second part, is from 6 to infinity. All right, our next one, 10b. So again, we're gonna see which one's increasing, decreasing, constant. So starting from here, going down, this decreases. This is constant. This part from left to right goes up, so that's going to increase. And this part goes down, which is decrease. All right, so increasing is from the x value of -1 to the x value of 2. Decreasing from -6 to -3. Union from 2 to 6. And where is it constant? From -3 to -1. Okay. All right, let's go to the next page. All right, so for this part, it says to determine whether the given functions are even, odd, or neither. So we look at the powers here. So right here, we have 4x squared, then we have 8, and there's no x. So watch what I'm going to do here. I'm going to add an x to the 8. So 4x squared plus 8 times x to the 0 power, right? So don't get confused there. 8 times x to the 0 power. We know that anything raised to the 0 power is 1, so 8 times 1 is actually 8. So I didn't actually change it. They're the same number. I just had an x to the 0, so you can see the difference between even and odd. All right, so first off, to determine whether it's even or odd, just using this trick here, we're going to look at the powers. So 2 is even, and so is 0. They're both even, so my answer for this problem is going to be even. All right, now we're going to check for even and odd again. So for this one here, we have x to the first power plus -3 and x to the 0. So we see that 1 is odd, but 0 is even. So it's not both even or both odd. They're mixed together. So that answer is going to be neither or neither. So it's neither even or odd. And then for the last one here, we have 4x squared minus x to the first plus 5x to the 0 power. So we have two evens, the 2 and the 0, but we have an odd, so they're mixed again. So the answer is neither. All right, so from here, we go to the next one. So it says use symmetry to determine whether the following graph is even or odd. So for this one here, you can look at the, I think it's the x-axis here, or the y-axis. And if you can flip it over that without changing it, like if it falls on top of itself, it would be even. In this case, if I just reflected it across the y-axis, it would not fall on itself, so it's not even. Odd means if you rotate this 180 degrees, it would fall on top of itself. But since this isn't even at the origin, that probably wouldn't happen here, because I can see this piece will end up over here, which means it doesn't fall on top of itself. And then obviously, since it's neither even or odd, the answer is neither or neither. For 15, first off, I need to rewrite this. So it should have been f of x equals, and we have two of them, so we have x plus 4. Then we have negative parentheses x plus 4. So the first one is if x is greater than or equal to negative 2. And the second one, it shouldn't have that equal bar, so I'm going to make it x is less than negative 2. Now, what I'm going to do is I'm going to check my x values and see which restriction they fall into. So for this first one, negative 6 is not greater than negative 2. Negative 6 is actually less than negative 2. So the first one is going to go right here. So we're going to take this negative 6 and plug it in here, which gives us negative parentheses, x is going to change to negative 6 plus 4. And you can just work that out. Negative 6 plus 4 is negative 2. And negative is positive, so you get a positive 2. For the next one, we got negative 2. Is negative 2 greater than or equal to negative 2, or is negative 2 less than negative 2? Well, we know it's not less than itself. It's actually equal to it, so it'd be this one right here. So we have negative 2 plus 4, which is going to give us positive 2. And then last, we have 0. 0 is greater than or equal to negative 2, or 0 is less than negative 2. Actually, 0 is greater than or equal to negative 2. So we have 0 plus 4, which is just 4. All right, moving on to part 2 now. All right, so for these right here, 16 and 17, it says, describe the transformations of the given functions, which we kind of know these already. So this is vertex form, but you just got to be able to identify where A, H, and K are. So A is in front of it, H is afterwards, and K is last. So H is always the opposite, moves it left or right. So the opposite of that is positive 2, so it goes to the right 2 units. K is up or down, and that's a positive 6, so it goes up 6. This one right here, again, this is A, H, and K. So A is less than 1 but greater than 0, so that's a vertical compression by 1/3. H opposite is negative 2, so it's actually going to the left 2, and then K is positive 5, so it goes up 5 units. All right, for number 18, it says to find the x and the y intercepts. So over here, I'll do that. I'll solve that over here. So I have the x-intercept, and then I have the y-intercept. So for the x-intercept, we just make y 0. So if we cover that up, we would see that 4x is equal to 8. And I'm going to set up the y-intercept. For the y-intercept, x is 0, so we can see that 2y is equal to 8. And then we just solve each one for its variable. So for x-intercept, I divide both sides by 4, and I get x is equal to 2. So my x-intercept is 2, 0. For the y-intercept, we divide both sides by 2, and y is equal to 4. So for the y-intercept, we get 0, 4. All right. Moving on to 19 through 21, it says to perform the indicated operation, write your answer in standard form. So standard form for a polynomial is just from left to right, highest to lowest degree. Okay, so for this one here, we don't really need the parentheses. So, and there's not enough room, so I'm not going to just get rid of them. I'm going to just combine like terms. So negative 4x to the fourth plus 8x to the fourth is going to give me 4x to the fourth. Negative 3x cubed plus negative 5x cubed is negative 8x cubed. 3x squared plus 9x squared is 12x squared. And then negative 2 minus 7 is negative 9. And I can combine those. Those are unlike terms. So that shit right there should be my final answer. All right, on to the next one. For this one, we're going to multiply. So we're going to distribute because there's no plus or minus sign between. So we know we're distributing, multiplying. So 9x times x squared is 9x to the third. 9x times negative 5 is negative 45x squared. 9x times 1 is positive 9x. Now I'm going to distribute the negative 1. Negative 1 times x squared is negative x squared. Negative 1 times negative 5 is positive 5x. And negative 1 times positive 1 is minus 1. So now we're just going to combine our like terms here. So we have only 9x cubed. There's no other cube term. We have negative 45x squared minus x squared, which should be negative 46x squared. Then we have 9x plus 4x, which is 14x. And then last we have this minus 1 by itself. And this is my simplified polynomial. And last, for the last one, it says 2x squared minus 7 squared. So to work this one out, we're going to write it twice. So it's going to be 2x squared minus 7 times 2x squared minus 7. And then we're just going to FOIL it out and see what we come up with. All right, so 2x squared times 2x squared is 4x to the fourth. 2x squared times negative 7 is negative 14x squared. Negative 7 times 2x squared is negative 14x squared. Negative 7 times negative 7 is positive 49. So we have 4x to the fourth. We have negative 14x squared minus 14x squared, which is negative 28x squared. And then we have a positive 49. All right, moving on to 22 through 24. The directions say factor the following polynomials or state the polynomial is prime, which just means it's not factorable. All right, for number 22, there's 3 terms. So I'm going to attempt to do the x method. So it's in standard form. There is no greatest common factor. There's no special cases. So we go to the x method. So b is on the top, which is 4. We do a times c. So 15 times negative 4 is negative 60. And we divide by a, which in this case is 15. So two numbers that add to 4 but multiply to negative 60 are going to be 10 and negative 6. 10 minus 6 is 4. 10 times negative 6 is negative 60. As you can see, we can reduce 10, 15 is going to reduce to 2/3. Negative 6 over 15 reduces to negative 2 over 5. So the 3 can't go into 2 evenly, so we bring the 3 in front of the x, so 3x plus 2. And then we get 5x minus 2, set that equal to 0, and it does want us to, it just wants us to factor. All right, so that is my answer right there. So let's actually write that underneath here. 3x plus 2 times 5x minus 2. All right, we're on to number 16 now. So for number 16, first off, I notice we have 4 terms. So this one, I'm going to attempt to factor by grouping. So I'm going to group the first 2 terms, and then I'm going to group the second 2 terms. So after you group them, you want to look at the GCF for the first 2 and then the GCF for the second 2. So the first 2, we have 3x squared in common, leaving us with x plus 2. For the second one, we have a positive 7 in common, leaving us again with x plus 2. So you notice these parentheses are the same. So we're going to bring that out in front as our common factor. And then whatever's left on the outside, we put in the second set of parentheses. So 3x squared plus 7. And that is our factored form. All right, last for number 17 here. So we have 5x cubed minus 125x. So it is standard form. It does have a GCF. They're both divisible by 5 and x to the first power. So that would be x squared minus 25. That's a difference of 2 squares. So 5x, that's going to be x plus 5 and x minus 5. It's one of those special cases. All right. For numbers 25 through 26, it's asking us to Simplify the following imaginary expression. So for the first one, we're just going to simply multiply it out. So we get, there's no plus or minus sign, so I'm going to multiply it. Negative 7 times 3 is negative 21. Negative 7 times I is negative 7i. Negative 3i times 3 is negative 9i. And negative 3i times I is negative 3i squared. If you recall from before, I squared is equal to negative 1. So then we can see we have negative 21. Negative 7i minus 9i is negative 16i. And this negative 3 is actually being multiplied by negative 1, which after we simplify, it becomes negative 21 minus 16i. Negative 1 times negative 3 is positive 3. And now hopefully you see we can actually combine negative 21 and 3 and get negative 18 minus 16i. And again, that right there is standard form because real before imaginary. All right, for the next one, we're dividing, but we have 7 plus 2i over 7 minus 2i. So we have to multiply by the complex conjugate. So the complex conjugate, all you have to do is flip the sign. So instead of 2 minus 7i, it becomes 2 plus 7i. And we're going to multiply that to the top and the bottom. So for the top, I'm going to simplify it. 7 times 2 is 14. 7 times 7i is positive 49i. 2i times 2 is positive 4i. And 2i times 7i is positive 14i squared. On the bottom, 2 times 2 is 4. 2 times 7i is 14i. Negative 7i times 2 is negative 14i. And negative 7i times 7i is negative 49i squared. On the top, we have 14. 49 plus 4i is positive 53i. We know that I squared is actually negative 1, so negative 1 times 14 is negative 14. On the bottom, we have 4. The two middle terms, 14i and negative 14i, cancel out. Then we have negative 49i squared, which is negative 49 times negative 1, which is positive 49. So right here, we can see the 14s cancel, leaving us with 53i divided by 4 plus 49 is also 53. And last, we can reduce these into 1i. All right, for 27 through 29, it says to solve it using your method choice. So for 27, I'm going to solve it by square roots. So we have 7x plus 3 squared is equal to 4. So we're doing PEMDAS backwards. There's no addition or subtraction outside the parentheses. There's no multiplication or division, but we do have an exponent of 2, so we take the square root of both sides, and we have a plus or minus immediately. So the square root and square cancel out, leaving us with 7x plus 3. The square root of 4 is plus or minus 2. To isolate the x, we're going to start by subtracting the 3. So 7x equals negative 3 plus or minus 2. And I can't combine those because the 2, it has a plus or minus. And last, we divide both sides by 7, giving us x equals negative 3 plus or minus 2 divided by 7. So here we're going to work these out separately. So the first one is x equals negative 3 plus 2 divided by 7. And the second one is negative 3 minus 2 divided by 7. So negative 3 plus 2 is negative 1. All right, so negative 3 plus 2 is negative 1, so negative 1/7. Negative 3 minus 2 is negative 5 over 7, so negative 5/7. All right, let's take a look at number 28. So for question 28, again, I'm going to factor by square root. So 11x squared minus 33 is equal to 0. First thing I'm going to do is add the 33 to the other side. So 11x squared equals 33. We can divide by 11 to isolate the x squared. X squared equals 33 divided by 11 is 3. To get rid of the square, we take the square root. Don't forget to put plus minus. And x equals plus or minus the square root of 3. Because x is isolated, that is my final answer. All right, we have next number 29. So 2x squared minus 5x minus 3 is equal to 0. So since this one is a trinomial, I'm going to try to factor it. So it's in standard form. There's no greatest common factor. It's not a special case. We go to the x method. This is a, b, and c. So b is negative 5. A we divide by is 2, and then a times c, 2 times negative 3 is negative 6. So two numbers that add to negative 5 but multiply to negative 6 are going to be -6 and +1. So let's verify it. -6 plus 1 is -5. -6 times 1 is -6. So -6 divided by 2 is -3. So that's going to be x minus 3. The other one doesn't reduce, and we bring the 2 in front of the x, so 2x plus 1. So now we're going to set each factor equal to 0 and solve it. So in this one, we would add the 3, and x equals 3. For the second one, we would first subtract 1. Then we would divide by 2, and x equals -1/2. All right. And now we're on to the next part. So this is going to be part 3 right here. All right, so for part 3, it says, find the coordinates of the vertex of the parabola defined by the given quadratic equation. So the first one is in vertex form. So in case you've forgotten, your vertex is h comma k. So for this one, this is a, h, and k. So the opposite of -2 is +2, right? So that vertex is going to be +2, comma, k is just -5. That doesn't change. So there's my vertex right there. For our second one, it's in standard form. So first we have to find the axis of symmetry, which x equals the opposite of b over 2a. And then we plug that into the vertex, and it's the opposite of b over 2a when you plug this in. So actually, let's write f of x, reminding us to plug that x value in. Okay, so I'm going to figure this out. So for x equals this is a is -1, b is -6, and c is 2. So opposite of b, so the opposite of -6 is 6, divided by 2 times -1, which is 6 divided by -2 is -3. So in terms of my vertex, it is -3, comma, and what we're going to do is we're going to take that -3, plug it into the function. So we have negative parentheses, -3 squared minus 6 times -3 plus 2. And when you work that out, you get 9, -9. -9 plus 18 is 27. Plus that 2 is going to give me, let's verify this. I don't want to make a mistake here. Okay, so we have negative parentheses, -3, close parentheses squared, minus 6 times -3 plus 2, and we get 11. All right, I just want to verify to make sure I got that right. I didn't want to make a mistake there. And there we go. All right, for the last one, it is also going to be the axis of symmetry and then plug it in. So we already know how to do this. So x equals a is 1, b is -14, c is 4. So opposite of b is 14 divided by 2 times a, which is 1, which gives me 7. So for my vertex, we have 7, comma. I'm going to plug that 7 in here. So 7 squared minus 14 times 7 plus 4. All right, so for this one, we're just going to plug it in here. So we have parentheses 7 close parentheses squared minus 14 times 7 plus 4. And we get -45. So 7 comma -45 is my answer. There we go. All right. We're on to number 33. So it says f of x equals x plus 3 squared minus 9. Find the y-intercept. So to find the y-intercept, what we're going to do is we're going to set x equal to 0. And then we're going to plug it in. So y equals 0 plus 3 squared minus 9. And 3 squared is 9. 9 minus 9 is 0. So my y-intercept is 0, comma 0. There's my answer. All right, for 34 and 35, it says to determine whether it's a polynomial function or not. So for this one here, to be a polynomial, it has to be a positive whole number for your exponent. Anything other than that is not going to work. So right here, we have the square root of x cubed, which can be written as 3 raised to the second power. So that's a fraction right there. That's not a whole number. Because of that, this is not a polynomial function. For the next one, we have x to the 7th, x to the 6th, and x to the 1st. They are all positive whole numbers. Yes, that is a polynomial function. All right, on to 36. It says, Find all the roots of the polynomial function, state the multiplicity of each, and behavior of the graph at each root. Okay, so we're going to find each solution. So for the first one, we're going to say x squared is equal to 0. So x equals 0. For the second one, x plus 7 equals 0. X equals negative 7. And then x minus 7 equals 0. So x is equal to 7 when you move it over. So these are my solutions. For the multiplicity, we look at the power. So this one is x squared, which is 2. For negative 7, there is no power on the x or on the outside, so we assume it to be 1. And x minus 7, we have a power of 1 there and 1 there, so the multiplicity is 1. Now, if your multiplicity is even, like the 2, it's going to touch the graph and turn at that x value. If it's odd, like the next ones are both 1s, it's going to cross the x-axis. All right, on to the next problem. Find the y-intercept of this polynomial. So again, we plug in x equals 0 and we work it out. So y equals 0 minus 2 squared, parentheses 0 squared minus 9. So 0 minus 2 is negative 2, squared is 4. 0 minus 9 is negative 9, and 4 times negative 9, it looks like it should be negative 36. So my y-intercept is 0, negative 36. All right, moving on past here. So this one says to use the leading coefficient test to determine the end behavior. So the first thing you're going to start off with is the degree. Now you'll notice all these are being multiplied. So we have a power of 3, a power of 1, and a power of 2. So we're going to add those up, 3, 4, 5, 6. So the degree is 6, which is even. We're really focused on that even. The leading coefficient is negative 6, and that is a negative number. So if we have even and negative, the end behavior, your graph goes down, falls to the left, and it falls to the right. All right, for number 39, it says to find the zeros of the polynomial by factoring it. Okay, so this has 4 terms. We're going to attempt to group it. So we see there these first two have x squared in common, leaving me with x plus 5. The second ones have negative 4 in common, leaving me again with x plus 5. So they both have that x plus 5. So x plus 5 I'm going to put in the front, but then what's left over is x squared minus 4. We know that the x squared minus 4 is a difference to squares, so that becomes the square root of that is x. The square root of 4 is 2. First one I always like to make positive, the second one negative. Now when we're getting our solutions, we set each one equal to 0, x plus 5 equals 0. So when we subtract the 5, x equals negative 5. The second one, x plus 2 is equal to 0, subtract the 2, x equals negative 2. And for the last one, x minus 2 equals 0, we add the 2 to the other side, x equals positive 2. And those are my 3 solutions, or my zeros, to the polynomial after I factored it. There we go. All right, we're down to the last 2 problems. So it wants us to perform long division and then synthetic division. So for this first one here, let me go ahead and do synthetic division first, just because it seems like it's going to be shorter. So first we take our divisor, set it equal to 0, and solve it. So x would equal 5. Then from the dividend, we use the leading coefficients, making sure no power is missing. If there is one missing, we put a 0 in its place. So we have x squared, we have x to the first, and then constant. So my coefficients are 2, negative 7, and negative 15. So we drop the first term, and then we multiply the pivot. 5 times 2 is 10. Combine, which is 3. 5 times 3 is 15. Combine, you get 0. So the remainder is 0. So my answer, I drop 1 power from x squared to x, so 2x plus 3. All right, and for the last one, number 40, I'm going to go ahead and do long division here. So I'm going to set it up. Negative 2x plus 5 is my divisor, and there's no missing powers. For my dividend, I have negative 6x cubed plus 9x squared plus 13x plus the 6. All right, we're going to go ahead and divide these. So we take the leading term of the dividend, negative 6x cubed, and we divide it by the leading term of the divisor, which is negative 2x, which gives me 3x squared. And that is going to go at the top right here. So we have 3x squared. And we know we have to apply it 3 times. 1, 2, 3. 3x squared times negative 2x is negative 6x to the third. 3x squared times 5 is 15x squared. Then we flip the signs, and then we combine. So the x cubes do cancel. 9x minus 15x squared is going to be negative 6x squared, and we bring down our next term. And we repeat the process. My new leading term is negative 16x squared, or sorry, negative 6x squared. We're going to divide that by negative 2x, and we get 3x. So that's going to be positive 3x. 3x times negative 2 is negative 6x. 3x times 5 is 15x. Flip the signs. So the x squared is canceled. 13x minus 15x is negative 2x. Bring down your positive 6. Then we're going to apply this process one more time. We're going to take the leading term negative 2x, divide by our leading term negative 2x, and we do get 1. So 1 times negative 2x is negative 2x. 1 times 5 is 5. We flip the signs. And x is canceled. 6 minus 5 is 1. So my final answer will be written as 3x squared plus 3x plus 1 plus the remainder of 1 over the divisor of negative 2x plus 5. All right, so my last thing is, let's see right here. So you do have a writing prompt. It says, look over this review and choose one problem and explain in words how to solve it. Be sure to indicate which problem you are using. All right, that concludes the review.